So in this video we're going to go over the definition of continuity. And let's say we have a function f of x over an interval a comma b. And the simple way to think of continuity is that if you can graph this function f of x over this interval without lifting your pen or pencil, then the function is continuous. But what we're curious about today is f of x continuous at a point x equals c? So we're not curious about if this function is continuous over an interval, we just care about this point x equals c. So there are three conditions that must be met for the function to be continuous at the point x equals c. So the first one is rather straightforward, and it says that f of c exists. So there just must be a y value that corresponds to c. And the second condition is that the limit as x approaches c of f of x exists. And remember that in order for this limit to exist, the left and right side limits have to be equal to each other. And the third condition basically just says that the first two conditions are equal to each other. So the limit as x approaches c of f of x equals f of c. So once you memorize the first two conditions, then the third condition is straightforward as well, and it's just that the first two conditions are equal to each other. And now we can put these conditions to use with an example. So let's say we have a piecewise function f of x equals x plus 1 if x is less than 2, and 2x minus 1 if x is greater than or equal to 2. So we want to know, is f of x continuous at x equals 2? So remember, there are three conditions that must be met. So the first condition is that f of c exists. So if we apply it to this question, f of 2 must exist. And we can see from the bottom part of this piecewise function that we can plug in 2 to 2x minus 1, and we get 2 times 2 minus 1 equals 3. So we know that f of 2 equals 3. And the second condition is that the limit as x approaches c of f of x exists. So in this context, the limit as x approaches 2 of f of x must exist. So if we evaluate the left side limit first, we can plug in 2 to x plus 1 and we get 3. And then if we evaluate the right side limit, we can plug in 2 to 2x minus 1 and we get 2 times 2 minus 1 is 3 as well. So the left and right side limits exist. So we know that the limit as x approaches 2 of f of x equals 3. So far the first two conditions are satisfied. And the third condition basically says if the first two conditions exist and they're equal to each other, then the third condition is satisfied. So f of 2 is equal to 3, and the limit as x approaches 2 of the function is also equal to 3. So we can just say that 3 is equal to 3. So we know that all three conditions satisfy, and therefore f of x is continuous at the point x equals 2. So our answer is yes, f of x is continuous at x equals 2.